Hi, my name is Kush and I'm a senior at UNC studying computer science, and this is my project on high dynamic range images, or HDR. So the problem we're given is that in the real world, we have a wide range of light that you can experience in different settings. So outside, you'll have lots of light, and when you come inside, you'll get less so, and you can go into a dark room where it's even less. And naturally, this is a huge range, but cameras can only capture a small range at a time. So what if we take images at different exposure levels like we have here, and you can just do that by changing the shutter speed to let in different amounts of light. And if we take a bunch of these images, can we combine these all into one to create a high dynamic range image? So the very first method we use to try to achieve this is this mean method. And I just followed the instructions that were given that we also learned in class, where we basically normalize all the pixels according to their exposure value. And then we basically just average each pixel between all the images, and this is what we get. So clearly it looks really bad. There's a lot of artifacts here on the top and bottom because of just the alignment. So this definitely is not ideal. So the next method we use is the weighted average method. So this is the one where I kind of change it up a bit. So we were first given this one idea, which is the cutoffs, which is the one in the middle, which is what we learned in class, where we just we remove the bottom 10% and the top 10%. And we basically getting rid of the over and under exposed areas, and we could put that all together and average it just like we did before. So we get a pretty good image. We do get some green artifacts at the very bottom, but it looks pretty good. But then we also have this other thing that was discussed, which is this weight function, where basically it maximizes at the very middle and goes to zero at the top and bottom at 0 and 255. So on the left, you see what if we just use that? It looks better than the first, but not that much better. And then on the right, we have what if we use both the cutoff and then the weight function afterwards. I think it looks slightly better, but not too much of a difference. After that, we use the median method. So for this one, we just used the cutoff, and then we just took the median exposure value from there. So it did a lot of cool things for that one by just using the MATLAB find function. So I really thought that one was cool, and it looks honestly the best so far. And then we used the last one was the highest non-saturating exposure method, which basically just did the same thing where we changed the upper level cutoff. We moved it down to 80%, and you just take the highest exposure after that. So this one looks really yellow and honestly not great. You do kind of see shadows a bit more though, which has a benefit, but you also have some artifacts on the bottom. Finally, you have the advanced method. So we had this huge equation that we found that we were basically given, and basically it takes in like the XY coordinate of the image and image number, and we can generate the pixel value from there by putting it through by using a weight function, the same one we used for the weighted method actually, and also just by using this response function G that we're given, and the exposure as well. So this is the function we're given. It takes in some basic input. I won't go into that for time, but basically it's like a weight function of random value that's lambda and z value, which is the pixel at I and j, and then also just the exposures, the log of them. So this is the function that we get from this. So the idea is you want to smooth off this end as much as possible. And that's why I chose a lambda value of 45 in the end. It was just kind of guess and check until we got something nice. And this is the final image. So honestly, looks really good. You can see the glass panes pretty well here in the back. You can see the dark areas as well. So I like it. You do get some interesting artifacts where it's kind of blurry in the top right, but overall, it's a pretty good image. So the most challenging thing was definitely coming up with like a way that was the most efficient. I want to use as many MATLAB functions as possible, so it didn't take too long to run. But I think the final image was really cool, and I really enjoyed this project as a whole. So thank you.